Hello, Yawning Angel back again with an AMOS video of sorts. Have you ever found yourself playing a game in an arcade cabinet and thought to yourself, I can create that game in AMOS? Well, this video is about just that, because a few months ago I was at the Arcade Archive, which is part of the Retro Collective, and I was playing on the arcade cabinet Space Race. While playing it, I thought to myself, do you know, I could have a stab at recreating this in AMOS. For those of you who don't know much about Space Race, Neil and the team have put together a full video on how they got this game up and running and how Richard 3D printed the entire cabinet for it. It's a great video and worth a watch, and I'll put a link to it in the description down below. The game itself is really quite straightforward. There are two spaceships on the screen, so two players can take a spaceship each and guide their spaceship from the bottom of the screen up to the top. When they get to the top, they get a point and the ship repositions to the bottom of the screen. While doing this, the players need to avoid meteors that are coming in from the left and the right, and if a meteor hits any of the ships are automatically put down to the bottom of the screen. Oh, and all this is done against a timer as well. So this type of game mechanic lends itself to AMOS very nicely. So in taking a very simplistic approach with no official game specs, I have recreated this game in AMOS. And I've built it based on the number of times I've played the game each time I've been up to the Arcade Archive, and also some wild assumptions as well on how I think it should work. Take note, this is not a carbon copy of the game which is in the arcade cabinet, but I like to think it's pretty close. So, playing a game which comprises of 391 lines of code, approximately, against a timer of 1.5 minutes, kind of. See if you and a friend not mandatory. See if you can get your ships to the top of the screen as often as you can in order to score points before the timer runs out. So what we're going to do, we're going to have a quick look at the game with one player playing it, and then we're going to review the code. The code will be available to download for free from my website. There'll be a link down below to that. Please note, if you're going to do so, you're going to need the AMCAF extension to play this game, because there's a couple of elements within the code where I've made use of AMCAF because it's just quicker and easier than trying to do it in AMOS Pro itself. I did cover the AMCAF installation in a video some time ago. There'll be a link up here somewhere to that. Right, so without further ado, let's dive in and see how the game handles and what this is all about. Okay, here I am in the code. We're going to do a code review in a bit, but I just want to show you the game being played single player as it were. Right, so joystick at the ready, joystick at the ready, and F1 and let's start. So here we are. My ship is the one on the right, and I can move, let's get that in shot. I can move up and down. That's not a problem. Obviously there's no left or right. The fire button doesn't do anything. In the middle of the screen there is a bar, a vertical bar, and then there's a little nodule on there which is moving down, and that's your countdown timer. So basically I need to move my ship, get it to the top of the screen. So I've now got to avoid these meteors, and if one hits the ship, it makes the boom noise and puts my ship back down to the bottom of the screen. And it's really difficult trying to talk and play this at the same time. But this is it. This is Space Race AMOS. And it does require a bit of concentration. The meteors, you might notice, are a little bit random. And I'll talk about that when I do the code review. So this is obviously not a like for like against the Space Race arcade cabinet up at the Arcade Archive. But it's a pretty damn close representation as far as I'm concerned. So let's just play this through. If you have concentration, you can get quite a high score. And if you notice that timer is running out. Oh, come on. Yeah, there we go. Timer has run out. I've got a score of 11. That's it really, happy days. Really simple game, really simple to run through. It's all pretty cool. But, Yawning Angel, I hear you ask, does this play well enough with two players? Well, yes it does. And here's some footage of myself and Mrs. Yawning Angel playing it only the other night. The game handles incredibly well for 2 players, really enjoyable, does give you a sense of purpose and gives you a bit of a challenge as well. So yes, it works fantastically well in 2-player. In AMOS, of course, quite easy to control or scan for 2 joysticks being used and control 2 separate blobs on the screen using those joysticks. It's really quite easy, but we'll check that out when we review the code. Right then, code review. First of all, cup of tea is in order. It's the official Cave Dweller mug. I don't have an Arcade Archive mug. Curious. But the tea tastes good regardless. Right, so the code here evolved over quite some time. I spent a lot of time playing around with the concept. I'm not going to show you all the code, but if these are the different versions here. We've got, different concepts and whatever, and eventually we came up, I came up with the final version. So it was many nights sitting, coding, trying different ideas. I did have some challenges around the meteors, also the countdown timer as well. But, I got there, and there is the version which we're going to look at now. You'll probably notice here in my file list there's a Space Race 2 concept. Yes, we may have a little look at that later. There's no mechanics, but I have started working on some graphics. But anyway, those are the different versions. Various different concepts were tried and tested, and I eventually got to the version which we are looking at now. Don't forget the code. This source code will be available to download from my website for free, but you will need the AMCAF extension in order to make full use of the functionality within here, because some things I just couldn't do in normal AMOS, and the AMCAF extensions helped out, especially when it came to time calculations. Right, let's go through this code then, and let me kill that sound because we don't want that. Right, so effectively it's just one screen. Screen 1, everything is taking place on screen 1 in this, which is fantastic. Then we load our bobs. So we've got an ABK file there, we load our bobs in, and then we do bob stuff. So I've got quite a lot of comments in this code, and some of them are a little bit more well detailed than others because it depends what time of night it was when I was writing them. So we get our bob palette, we do double buffer, make mask, because obviously we got collision detection around the meteors for when they hit the ship. So we define variables. Now the meteors is quite interesting. So we've got meteors coming from the right and the left of the screen. So what I thought I'd do is just create 2 arrays, and we'd have 13 meteors on each side that will be moving across the screen. So the arrays I've dimensioned here, L and R meteors, so the left and right, calculations are exactly the same for each, apart from direction, and we'll look at that later. So we define 13 meteors, and then I define positions for X and Y coordinates on those meteors. And what happens there is we populate, I keep saying I do not have a multiple personality disorder, trust me. I then randomize the values for the X and Y coordinates. So for each meteor, it has a random X and Y coordinate, and that's how it's positioned on the screen. So this for loop here, we just go through for each meteor, and for the X coordinates, it's any number between 0 and 300. For any Y coordinates, it's between 0 and 160, because obviously that's the size of the screen. And I do that for the left and the right meteors. So one thing I do want to say here is I'm not going into the nth degree on this code review. It's just to basically give you a quick overview. It's not a code review, it's a code overview, really. So, the comments are there. You'll be able to get the code, have a look at it yourself, and work things out in more detail if you wish to. Right, so then I define the values, the start positions for player 1 ship and the player 2 ship, where they're going to be on the screen. I set their scores to 0. And I've got some speed indicators here. I've got a timer position. I've got some global variables defined here, more global variables, some specific to the meteors, different positions and speed. There are probably some variables in here looking at this now that can probably come out because they aren't used, because I've changed this code so many times. Anyway, quick and dirty, maybe. Define our screen colors, and then we set a font. Now the font we're using here, this HCT font, this is for the scores and obviously for the game over message. I just wanted something big and bold, and I just thought I'd use the AMCAF font handling on this because it's just so much easier to do. The timer, so the countdown timer, the vertical bar on the screen has got a little nodule on it which comes down the screen. That, to work out the time of that, I've got this down to about 1.5 minutes. That's how long a game is. That's the duration of your play. And I really just had to use, I wanted to get the time, and then I needed to work out the seconds, and then work out the 50th of a second kind of values to then determine how far that bar comes down the screen. So what this does here, this value, we just grab the current time. So current time is an AMCAF command. It is not an AMOS command. And I set that in a value, and then I just display this timer bar in the middle of the screen. It's actually a bob. It's not a solid bar. I did it as a bob because it just was easier. You may find an easier way to do this yourself, but I was just desperate to try and get something working. And then I've got a bob here, which will be the blob that moves down that bar. From the time I got up here, the current time, into this st_time value, I extract the seconds, right? So because I'm using the seconds to count. So I extract the seconds from the time. Once again, this CT second is an AMCAF command. I then just display the default scores. So I set the current time again here at the start of the loop. So there's still some rogue code in here. You might want to take some of this out. There might well be in amongst the code, when you look at it, some debug commands, because I was trying to work out, well, not debug commands, but debug code that would show me the values of stuff as it was happening. And I've left some of them in because you never know when you're going to need them again. So I appear to be setting the time again here, so I might need to tidy this up before I release this code. I then extract the seconds, and then I extract the minutes as well. So I've got the time value, the second value, and the minute value. They're stored. And I've set a counter here for the number of seconds that have been counted. This will become clearer later on. And then with all those values set, are you still with me? We're going to dive into the main program loop, and we're going to grab a mouthful of tea, and we're going to do that next. Right, the main program loop. Oh, tea tastes so good. Love me a cup of tea. Right, let's take a look then. So the main loop of the program. We put our player 1 bob on the ship on the screen, and we put our player 2 bob on the screen, and these have their positions using bob number 7 from the ABK file. We then have a procedure which handles our meteors moving across the screen. We'll have a look at that in a bit. Wait VBL, standard stuff. We've got a check in here to check to see if we've run out of time, if the game is now over. So what that is actually doing, this isn't actually checking the time as such. This is just checking the value of that blob which is moving down the timer bar. And if it gets to the bottom of the screen, bang, game over, man, game over. Is there any collision detection? So if our player 2 bob collides with anything, make the boom sound and reposition the ship to the bottom of the screen. If our player 1 bob hits anything on the screen, a meteor, then obviously play the boom sound, reposition. Joysticks and stuff. So we've got joystick up and joystick down for both players here. So that is, yeah, standard stuff. We just basically, adjust the speed accordingly, either you're moving up or you're moving down. Not speed as such, in terms of the movement of the ship. So there's a little optional bit here, which I've commented out, but I've left it in the program. So this is inertia. I put inertia in the program. So if your ship was just sitting still, it would start to drop back down. So you would have to constantly hold it in position. And the reason I did this is because I thought the arcade game actually did this. And it was only when speaking to Neil at the cave, I realised, where he told me, that actually the joystick was a bit iffy. And so the ship would just fall anyway. So I've commented this out, but I think I'm going to leave it there. If you want to use it, feel free, just uncomment it. But I will make this a feature of the version 2 of the game, because that kind of sounds like a fun thing. So you're fighting your ship pretty much all the time. I don't know, it's a cool thing. Has your ship made it to the top of the screen? We just check the position. If you have, increment the score and then reposition the ship to the bottom of the screen. And this code here does that for the player 1 and player 2. Bit of code in here to prevent the ship from going below the bottom of the screen. So it just means if you're at the bottom of the screen, you pull the joystick down, the ship isn't going anywhere. It's just going to stay exactly where it is. So then we look at our time calculation, and we'll go through that next. Right, let's look at the time calculation. Ugh, a shudder. This caused me much angst. Calculating time in programs, in computer programs that don't have the right mechanics to do it easily, really makes my brain itch. So I've struggled with this. I've rewritten this routine about 2 or 3 times. This is why I used AMCAF, because it was just easier. In actual AMOS, I just couldn't get my head around it. So there are people out there who can probably do this quite easily. Rob Smith Dev, I'm looking at you. So now if you remember at the top of the loop, I captured the current time and I stored that in a value. Now I've hit this bit of code, I capture the current time again and I store it in a second value. And then what I do, I effectively subtract, I extract the seconds and the minutes from that second value, which is exactly what I did when I captured it at the top of the loop. So now I've got like a start time and a current time. Then I subtract the seconds and the minutes between the two and I check for a difference. We'll go through this comment in a minute, but what we're effectively doing is if the second, if there's a difference of at least a second, I increment this second counter. This is just an integer value. And basically I can have 110 instances of this, or 110 is the value within there. And that will give us 1 minute and 30 seconds of gameplay, approximately. This is down to the whole 50th of a second thing. I'm not going to go into the huge maths here because I'll make myself look like an idiot and try to explain it. But this kind of works. So basically, if there's a difference in the seconds, we increment the second counter. If the second counter has hit 110, we go out to a handle timer. And that will be a procedure which actually moves that blob. Then what I do is I take the value of time which I've just stored here and I move that into the first value because the next time round I'll have a new second value and I'll need to subtract that from the old first value, if that kind of makes sense. And I reset my second counter to 0. Now, when I was doing this, I did notice that where we had things where seconds, there were differences. So if your first time the seconds were 0 and the next time through they were like 50 or something, we could get some miscalculations going on there. There could be some negative numbers and all the rest of it, because obviously it needs to take into account minutes as well. So there's a minute difference as well. So if a minute has passed on top of that, so if the minutes have changed, we still increment our set counter. Once again, check for the 110, handle the timer, reset values, and off you go. It's not my strongest area of programming, I will say that now. So if anybody out there can come up with a better way of doing this, please do so. But this works and it gives us, like I said, roughly about 1.5 minutes of gameplay, which, isn't bad. I mean, I'm quite happy with that. It seems to work all right. That is the end of our main loop. So next up, let's have a look at the meteors, because there's some tricksy stuff going on in here. So the meteor, it's a procedure which handles meteors coming from the left and coming from the right. So it's not overly complex. But what I do, so I've got that array. I've got an array of 13 elements, 13 meteors. And what this bit of code does, it goes through each element in that array and it positions the bob, because the meteors are bobs at the end of the day. It's just obviously one graphic, one bob, and we just replicate that for all the meteors. So this line here, the first one it does, it positions it. I'm not going to go through all these values, we'll be here for days, but effectively this is a standard bob command. The bob number, our X position and our Y position, and the actual bob that we're taking from the banks. In this case, it is bob 4. The next line will move it. So that positions it. So we set its X position, we increment it by the speed, effectively. Then our next line checks, has that meteor actually got to the edge of the screen now? Has it moved all the way across? So for this one, has it got to the edge of the screen as it hits, 300? So it's gone off the edge of the screen, but what I want to do now is reposition it. Now I could just bring it straight back and we could just carry on again, but I thought I'd be a little bit crafty. And what I actually do here is I regenerate the X coordinates for that meteor. Because what I noticed when testing this, we'd have our 13 meteors moving across the screen, left to right and right to left. And if the pattern had a lot of gaps in it, it would be quite easy for you just to hold your joystick up all the time and the ship would just fly through those gaps. There was no challenge. So I thought, why don't we reposition that, some of the meteors across the X coordinate? And that's what happens, which is why when you're playing it now, you'll see a gap, you'll move your ship into it, and all of a sudden a meteor will just appear and just slam into your ship. And I like that sort of deviousness in a game. So that's what this line does. It repositions, it reassigns effectively the X coordinate for the meteor. We do exactly the same for the right, although rather than checking as it hit 300 on its X position, we check for less than or equal to 0, because obviously it's going the other way. And that really is it. And I'm actually quite pleased with that. I'm pleased that works quite well. I'm very happy. The timer bar. Really, so this is this blob that we got moving down the screen. So when handle timer is called, basically what this means is that a second has passed and it triggers the repositioning of that bob, so it just moves down the screen. So we just increment it and the bob is redrawn, and that's really all there is to it. So nothing overly complex there. Game over procedure, well, really, this isn't rocket science. Basically just show game over, text on the screen. Text, please note, I'm not using print, I'm using text, so that big chunky text on the screen. I've got some test code in here as well, because I was checking the time. I might remove that before I actually release this code, because I was trying to work out, well, how long is this actually taking? And it was about 1.5 minutes, approximately. Displaying player scores when this is called, really it's just text commands again, which shows our player 1 score and our player 2 score. Nothing overly complex there. And that is the bottom of the code. So 391 lines of code, possibly a few more if I took out some of the commented outlines. But really, that's all there is to it. It's fairly straightforward. It's a fairly straightforward concept. Like I said, have a look at it, have a play with it. No doubt people out there can come up with some better ways of doing this, but I wanted to try and just prove the concept that this could be done in AMOS, and it does actually present quite a playable game, even if I say so myself. Right, I thought we'd have a quick look at the bobs that I came up with for this. So this, this bank file really has got every single bob that I created as part of my proof of concept for this game. That's what the ship looked like originally, which is, we've got to start somewhere. Then I thought I'd be a bit tricksy and put some, some like engine exhaust things going on there. I thought I might think about animating it. And then I thought, no, because the original game didn't have that. So this is my meteor, very, very simple graphic there. Down here, this is the line which will make the timer bar. Yeah, there's a better way of doing that, but that's a job for another day, really. Maybe version 2. This is the blob that moves down that bar. And then we've got our final ship. This is the ship. Some people have questioned the way it looks.
What is it, son? I don't know, sir. But it looks like a giant dick.
Looks a bit interesting, but this is what the original game ship looks like, so that's what I've stuck with. And that's really it. Those are the bobs. So effectively only 3 of those are in use in this version of the game, but I've left the rest in there kind of just for reasons, basically. But there we go. That's the bob file. Happy days. So what is the future for this project? Well, I want to take it to the next level, so to speak. I have already started work on a version 2 of this game. Yes, Space Race for AMOS version 2 is in the works. I've already decided to redesign the spaceship and have started working on that already, putting some animation into it, which I'm going to use AMAL for, to animate the ship within the game. Okay, so as mentioned, I have started working on a version 2 of this, and the first thing I want to address is some of the graphics. So I have made a tentative start on the ship graphics for a start. Please bear in mind, I am not a graphics artist. Regular viewers to this channel will know that. But here we are. This is what the ship is looking like now. It looks a bit more like a spaceship, and because I'm going to use AMAL to animate this within the game. So there are different versions of the ship here. So I've got 3 different versions. And if I go into this, into the kind of animator in here, I don't know if you can actually see that, but if I slow that down, maybe let's do it at, there we go. So, you know, the ship will actually animate and look a little bit more interesting. You know, just to make it look a bit more interesting, maybe I might do something as you're going forward, or when you go backwards, maybe some jets or propel you back. I don't know. There's a lot of options here that I can go for. So work has started. And I think, as I said earlier, you know, if anyone's got any ideas out there, the kind of thing, you know, I can put into this, please leave them in the comments down below as suggestions. I mean, you know, the world is our oyster here. Obviously, the meteors will be bigger. We can have different meteors do different things when they collide with the ship. Maybe have some UFOs flying across the screen that can be taken out for extra points. Loads of stuff. We can kind of go mad with this. But yeah, so there we go. Work on a version 2 has started. Leave your suggestions in the comments down below. I did just want to say quickly a big thank you to Dudley of Yesterzine for providing the image of the Space Race cabinet, which I have used in the thumbnail image. Thank you ever so much, Dudley. I really appreciate your time in getting that, because I really struggle to get a decent picture. Also, a very quick thank you to Neil and the crew at the Retro Collective for providing me with some video footage of the Space Race arcade cab and the game itself. That's helped me to build this video and actually build the game as well. So thanks a lot, guys. And that is it for another video. Thank you ever so much for watching. Don't forget you can download the code for this game for free from my website. Find me on the usual places. I've got a Ko-fi account. I'm on Blue Sky. Speak to me, leave comments down below. It's all good. Thanks once again for watching, and until the next video, look after yourselves and keep it retro. If you enjoyed this video, here's some others which you may find interesting.